Hi, my name is Will Pincek. I work for Juniper Networks. I'm an education services engineer. I'm going to do a learning byte on Contrail Enterprise Multicloud, and we'll be doing bare metal server multi-homing to two different networks. Instead of a single network with bonding or lag interfaces, this is going to be a bare metal server multi-homing to two different networks. So what is this multi-homing to different networks use case? This allows bare metal server to be attached to multiple overlay networks. The bare metal server is attached to one or more top-of-rack switches, and those top-of-rack switches will act as VXLAN gateways. Okay. Contrail Enterprise Multicloud will automatically configure the top-of-rack switches for the VXLAN overlay, which is the hard part, as you'll see. Okay. This is the logical topology we're looking at. We're hoping to take a bare metal server and multi-home it, two different interfaces, going to two different virtual networks, and be able to pass traffic between, for instance, VM1 that's also on the virtual network A, or being able to pass traffic between VM2 and the bare metal server over virtual network B. The bare metal server will not be a router, it'll simply be another device on the two different networks. But it'll be multi-homed. Okay, so this is that's kind of the logical topology we're trying to attain. This is the closer to reality of what's going to happen here. We're going to have two VMs, each on different virtual networks. So we have VM1 and VM2. They're each on different virtual networks. They're on a compute node. These are OpenStack VMs. That are running on top of two Contrail virtual networks. We'll have an IP fabric built on two leaf nodes and one spine node. We'll be doing central routing and bridging. So we'll have the leaf nodes will be central routing and bridging access. That will be their role, while the spine node will have a central routing and bridging gateway role. Let's see. The bare metal server will multi-home, that is, we'll have two interfaces, ETH1 going out to QFX 5102, ETH0 going out to QFX 5101. One interface will belong to bridge domain B, the other interface will belong to bridge domain A. Bridge domain A allows for the passing of traffic between VM1 and the bare metal server along this path, and bridge domain B allows for passing traffic to VM2 along this path across these VXLAN tunnels that are built from the QFX 5100s to the appropriate compute node. I've only shown compute 1 here, but there are actually two compute nodes in our topology, which I'll show you here in a brief moment. That's about all for the details I'm going to give you about what goes on here. I do have a different learning byte called Contrail Enterprise Multicloud VM to bare metal server bridging, where I go into it probably a little bit more detail than that. Suffice it to know that the hard part, which is the configuring of the QFX 5100s to be layer 2 VXLAN gateways, which is what they're doing here, is all going to be configured on your behalf by Contrail Enterprise Multicloud. And I'm going to show you what you need to do on Contrail Enterprise Multicloud to make this happen. So that's our goal. So in order to get this to work, we need a bare metal server configured with at least two interfaces. In our case, just two interfaces, and they should belong to two different subnets. The two interfaces can go to the same top-of-rack switch or different top-of-rack switches. In our case, they'll be going to different top-of-rack switches. There needs to be a Contrail cluster that has the Contrail command user interface in place. There needs VXLAN routing needs to be enabled, and also we need to have already onboarded an IP fabric that has an EVP and VXLAN gateway EVP and VXLAN overlay signaling that's already established. And this happens anytime you do either a greenfield or brownfield onboarding of an IP fabric, which I have a learning byte on those as well. So the spine nodes need to be assigned the CRB gateway role, and the leaf nodes need to be assigned the CRB access role. So we actually do, this is our topology, and this is its current state. I've got the IP fabric. I've got eBGP running between all of the members of the IP fabric so that we can ping, for instance, from compute 1 to compute 2. The routing is fully enabled with eBGP using IPv4 unicast. Okay. Then we also have a Contrail fabric established, which are these nodes along here. We've got an OpenStack orchestrator node. We've got a Contrail control node. We've got two Contrail compute nodes that are acting as OpenStack compute and Contrail vRouter nodes. And then we have a CSN that's there to provide DHCP and DNS server functionality to any bare metal servers that we might add to these leaf nodes. Now, also what we see here is there's a command server that has the command server installed. The command UI is here, so it's here that will interact with the command UI, and it will make things happen on the Contrail cluster down here, which includes pushing configs out to the IP fabric. So we've already onboarded this fabric as a brownfield IP fabric, which means that it's discovered these devices and also gone out. Contrail Enterprise Multicloud has gone out and configured an EVPN VXLAN overlay, at least the signaling. There's currently no actual forwarding of VXLAN traffic at this point because we haven't added any bare metal servers to it, but we should see that QFX 5100 10K QFX 10K is a route reflector. It's a CRB gateway role. It's the route reflector for these EVPN MPBGP IBGP sessions. It has a session with the control node, the QFX 5101 and the QFX 5102, and that was all pre-configured on your behalf during the brownfield the onboarding of this brownfield IP fabric. So let's go, and we'll go ahead and complete our task, let's look at a few things. First thing we're going to do is verify our bare metal server interface configuration. So currently I've got a bare metal server. Let's get that up here. Here's our bare metal server. It currently has both interfaces are down. Here we see here with the IP address command, we have ETH0 is down, ETH1 is down. If I look at their configs, and that's just admin down, I'm going to admin it up in a bit, but notice it's enabled for DHCP. So we're hoping that if we go back to this diagram, we've got a bare metal server that we're trying to add to our topology, which is here. With ETH0 and ETH1, we're hoping for these addresses to come via DHCP, which will be provided by the CSN in our network. Okay, so that's currently set up for what we want, which is DHCP. Let's get out of there. And okay, so we've done that. We want to make sure we have MPBGP enabled, because remember, we've got these because we onboarded this brownfield IP fabric. This overlay network should have been automatically configured for us. So let's double check that. We go then to QFX 10K. So on the QFX 10K, we could see all the sessions. So if I say show BGP summary, here we've got our eBGP sessions that are used for the underlay routing, okay, between all the subnets, and then we've got our IBGP overlay. So this was for underlay. Now we've got the 3 sessions for the overlay for using the EVPN signaling. 1 session established to the QFX 5101, 1 session established for QFX 5102, and then 1 to the control node. Okay, and that all happens based on the onboarding of the IP fabric. Okay, now we can do some cool stuff with it. In this case, we're going to add a bare metal server with a multi-homed interface to this, so we'll see a lot more routes being advertised here. You see a lot of zeros. That's because there's not a lot going on. We haven't added any bare metal servers yet. So let's go to the next step. So my next step is to verify my CRB roles of the fabric devices. If they're not performing the roles we need them to, then this will not work. So if I go to fabrics, you would have assigned these roles you would have assigned during the onboarding process, which is not covered in this course or in this learning byte. But here, the QFX 50 to 10K has route reflector role, DC gateway role, and the CRB gateway role, while the 5100s have the CRB access role, which is what we're hoping for them to have. We also want to verify VXLAN routing. We want to make sure that's enabled. That's under projects admin. Here we want to make sure that this slide button is moved over to enable, which it is. We also, as we mentioned, we want the CSN to provide DHCP services for any bare metal servers that we, DHCP and DNS service for any bare metal servers that we add to the IP fabric. So to do that, we need to assign that CSN to the various leaf nodes. So we do that under back to fabrics, under brownfield. We're in the same spot we were before. We go under, remember we're going to add the bare metal server to both, right? To both 5100s. It'll have an interface off of both. So we need the CSN assigned to both. So I'm just going to verify that sure enough, I added the CSN as a top of rack service node. Okay, so that's already been done on QFX 5101. It has also been done on QFX 5100 too. So these settings need to be there if we need DHCP and DNS services for our bare metal server, which in this case we do. So that's been verified. So that's good. We need to modify the default security group because remember we're going to be passing traffic in and out of these of the VMs and the bare metal servers. So we need to make sure our security policies are allowing traffic in and out of these devices. So the default and when I launch these VMs and bare metal services, bare metal servers, they're going to be assigned to the default security group. So let's modify the default security group. Here it is under overlay security groups. We click edit here, and it's under here that will set these on the ingress. So it's on the ingress that we're blocking right now. So let's make sure we go select CIDR here on the ingress side for IPv4. All addresses, the default is what we want, which is all zeros. And then same thing for IPv6, which we're not doing, but we'll go ahead and modify it anyways for all addresses. The egress side's already taken care of. So we allow anything out. It's inbound that we were blocking before. So we'll go ahead and save that. So it takes care of the security group. Okay, now we need to create these virtual networks. Remember, we have these two virtual networks. Virtual network A, which is 192.168.1.0, and we have virtual network B, which is 192.168.2.0. So we need to create those overlay networks, which we'll do here. We'll do that here on the Contrail command user interface. We'll go to virtual networks, and we will create both of them. Virtual network A, and we'll add a subnet. Okay, we'll add it from the default project IPAM. We'll specify the correct subnet, a DHCP allegation address pool. The gateway will stay the same. The default service address is 192.168.1.2, but you can make it anything you want. And then we'll specify that we want to provide DHCP and DNS, which is good. That's what we want. So that's VNA. Okay, then we need a second network. Okay, we'll call it VNB. We'll add a subnet. Add a subnet. We want this to be the address space. We want to allocate addresses from this pool of addresses, and we want to provide DHCP and DNS services. So we'll hit create. Okay, so now we've got our two networks. Now we'll start with creating the two VMs, right? So back here, we want to have two VMs, one VM attaching to virtual network A, one VM attaching to virtual network B, and we'll go ahead and create that first. Okay, so we do that under instances, under workloads, instances. We'll go ahead and create an OpenStack VM. So we go under virtual machine. We'll create VM1 from an image, a Ceros image I have, specifying this tiny flavor. I want it to be on VNA, and we need to specify the availability zone, which is Nova. We hit create, and this will launch our VM1 from our diagram. So that will launch our VM1. Hopefully that comes up. And then we'll go ahead and launch our VM2. So this one's coming up, but we'll go ahead and create a new one also. Well, that one comes up. So we'll create VM2 also from an image, Ceros image, tiny font. We're going to put it on VNB, and we'll set the availability zone to Nova. We'll hit create, and we'll see what happens. So VN1's up and running, so we're good there. It's been assigned the 192.168.1.0, or sorry, 1.100 address, and VM2 is coming up. It's been assigned the 2.100 address. Okay. All right. So now the last part is to add the bare metal server to this whole thing. So we start by adding the server, and then we have to add the instance. Okay, so that's what we're going to do here. Actually, let's create one BMS. All right, let me go ahead and fix that on the fly. And one BMS instance, right? Because this is one BMS that we're trying, bare metal server. Actually, it is two. I'm going to go back. It's two bare metal servers. That's right. I've got to think this out as I go. Thanks for putting up with me. It's two. Okay, when I'm multi-homing to two different networks, this is going to, from Contrail Enterprise Multicloud's point of view, it's going to be two separate servers. It's going to be treated like two separate servers. Okay, so they'll be configured on two separate VNIDs, for instance. Okay. All right, so we created our two VMs, we created our two bare metal server instances, one for each of the interfaces that are going to separate networks. So we go to servers, we're going to create a bare metal server. Okay, we're going to call it, we'll call it BMS, and then it'll be interface 1. Okay. Oh no, sorry, we got to do this under detailed. We have to do this under bare metal, and we're going to call it, so we'll call it BMS, BMSA, or BMS interface 1. Okay, that's what we'll call it. Then we'll specify the interface, which is first one's ETH0. Okay, and we'll call this interface 0. Why don't we call it ETH0 while we're at it? ETH0. We'll make it make sense. ETH0's MAC address. Let's go back and find it. Hopefully we can get to it, which we can. ETH0's MAC address we can see here ends in 2A3F, which I've put it in before, so it's going to show up here, 2A3F. And if we remember from our diagram, this is being attached on from ETH0 to GIGI004 on QFX5101. So we make sure to set QFX5101 GIGI004. So all we're doing is doing a MAC address to interface mapping. Interface and TOR mapping. That's all being mapped. Okay, then we'll add another, no, we don't add another interface. I'll take that back. So that's it. That's all we have to do for that interface. Okay, so we'll say create. We're going to add another bare metal server here. Okay, detailed. Bare metal, we'll call it BMS ETH1. Okay. We'll call it interface is ETH1. The MAC address is 1799, I know that. And we're attaching it to QFX5102 GIGI004, if you remember. Let's just take a peek. So ETH1 is attached to GIGI004 on QFX5102, which is what we had. Okay, and we'll say create. Okay, so now we've now done the mapping of MAC address to TOR and TOR interface, but nothing's actually been configured. So we've just kind of reserved those ports for those for that top of rack, sorry, for that bare metal server. So now we need to launch the instance. So we'll go here to instances, and we're going to add two bare metal server instances over here. So we'll add the first one using we'll do the existing bare metal server. The instance name, we'll call it BMS. We'll also call it E0. Okay, and the bare metal node will be BMS E0, the one we configured before. We'll specify from the drop-down window, specify the interface there. No IP address because we're getting it from DHCP. No VLAN tagging, and it's going to be on virtual network A on the default security group. And that will, once I hit create here, this is where it's going to go and configure. Remember, this is mapped to the QFX5101 GIGI004 interface. When I hit create, Contrail Enterprise Multicloud is going to go out and configure QFX5101 for that interface and for the layer 2 VXLAN gateway functionality on your behalf. So you don't actually have to go in there and configure it. Now, what I like to do before I go on is I like to make sure that it's done. configuring QFX 5101. So what I do is I go to I go to the control node and do a tail -F and look at the logs for the Ansible playbooks. So I go to var log Contrail fabric Ansible playbook log. So I'm doing a tail on that. And here we can actually see this is the playbooks that are being run on the Contrail control node. So what it's actually doing is building the configuration for QFX 5101, which there's quite a bit of configuration for that it's going to do on your behalf, and then it's going to push that config out to the 5101. So it takes some time. I don't like to move on until this is complete, so I watch these log messages until they complete. So I'm going to go ahead and do that and come back once it's finished. Okay, it appears to have finished because the logs have stopped. It's said failed 0. We're good. So everything looks fine there. I can go to the 5101, which is here, and if I say show pipe compare rollback 1, here I can see the changes that it did for me, right? So it went and configured a new VNI 5. It's going to configure the policies. It's configured GIGI004 to do the layer 2 VXLAN gateway functionality for it. So it's all done for me with just a few clicks of the button. Okay, so the left side of the diagram is complete. So let me bring that up. So this is complete. I should be able to pass traffic to VM1, okay, from the bare metal server. But let's go ahead and complete the this right side now as well. So we do that by going back to here, and we create another instance. Okay, I'm going to call it well, we do an existing bare metal server. I'm going to call it BMS ETH1. And I'm going to select the server that I had, which is BMS ETH1. The interface is ETH1. No IP address because I want to get it from DHCP. 0 for VLAN, no VLAN tagging. On VLAN, virtual network B, and the default security group. And that's it. And I hit create again. It will now tell the control node to go ahead and build those configs and run the Ansible scripts to build the configs and also push them out to the QFX 5102, which is what we see here. So I'm still tailing on that Contrail. Well, we'll see it again. I'll just stop it, and here's the command I use. Again, it's tail -F var log Contrail fabric Ansible playbooks log, and here we see that I'm tailing on it, so it's working. I'm going to wait for that to finish and come back. Okay, so it appears to have finished. So we can go double check that. I can go to QFX 5102, and I can say show pipe compare rollback 1 to see what was configured. And sure enough, another VNI has been configured. GIGI004 has been configured to so that the top of this device will perform layer 2 VXLAN gateway functionality. So it's everything we want. So that we should be complete, so we can test it. If we go back, let's remember that our VMs are numbered 1.100 and 2.100. So from the bare metal server, I should be able to ping both of those. Okay, so I have my single bare metal server. Also, remember, I had these interfaces as down, so I have to bring these up. So I'm going to say if up ETH0, bring it up. Okay, and it's going to try and do DHCP to get its IP address from the CSN, which it did. Good. And I'm going to do the same thing for 1, which there it should also get an IP address from the CSN over the VXLAN network, which it does. If I say IP address, okay, now it's got its address. Notice it's 101 and 101, which is the same as what was assigned here, right? So they all match up. Now let's just make sure I can finish up with the ping. So I will ping to 192.168.1.100. See, I can ping the VM1, and can I ping VM2? Let's figure that out. 2.100. Sure enough, I can ping there. So I've done a multi-homed bare metal server that's homing to 2 different virtual networks. And that completes that learning byte. So what do? We describe the steps to use Contrail Enterprise Multicloud to help attach a bare metal server to different overlay networks. I hope that was helpful, And I hope you enjoy my other learning bites as well on Contrail Enterprise Multicloud.
Visit the Juniper Education Services website to learn more about courses. View our full range of classroom, online, and e-learning courses. Learning paths, industry segment and technology-specific training paths. Juniper Networks Certification Program, the ultimate demonstration of your competence. And the training community, from forums to social media. Join the discussion.